Hello, welcome to the world of chemistry. This is Dr. Vikram Panchal and I'm dealing with spectroscopy. And in this lecture, lecture number 7, I will explain you UV visible spectra. So first of all, let us see what is UV visible light. UV visible light is before X-rays and after X-rays and before infrared. This light is very important, in which we observe visible light. That means we observe 7 colors also. And if you see wavelength of light, then UV starts from, for us, 200 nanometer is very important, to 400 nanometer, and visible is up to 750 nanometer. So this is the normal range. It can extend up to 800 nanometer also, but this is the normal range of ultraviolet visible light. Frequency, if we see frequency of UV radiation is about 10 raised to 15 hertz, and frequency of visible light is 10 raised to 14 hertz. Okay. When molecule absorb UV visible radiations, what kind of change appear? That is very important. So when molecule absorb UV visible light, then bonding electron or electron from lone pair, that is non-bonding electron, can transfer from BMO, bonding molecular orbital, or N orbital in which we find lone pair of electron, to ABMO orbital. Okay. So in this case, we are normally referring bonding molecular orbital, anti-bonding molecular orbital, or N orbital according to molecular orbital theory. I hope you must be knowing what is bonding molecular orbital, N orbital, and anti-bonding molecular orbital. There are mainly two types of covalent bonds. One is sigma bond, in which sharing of electron pair takes place between two non-metal atoms. And here direct overlapping produce sigma bond, single bond. So if you write single bond between two atoms like this, C single bond O, then this is sigma bond. There will be two electrons in sigma bond. Okay. Now, due to change or due to absorption of UV light, visible light, if this electron travel to ABMO, that means BMO electron, one of these BMO electron transfer to ABMO, then it can be like this, CO. Now only one electron left over here between carbon and oxygen, and one electron will go to anti-bonding molecular orbital. Okay, sorry, not here. It is in the same plane, so it can be here somewhere. Okay, So here this is BMO orbital, and here there will be anti-bonding molecular orbital of sigma type. So this kind of transition is known as sigma to sigma star transition. Okay, this is due to absorption of ultraviolet visible light. Second type of bond is pi bond. Suppose we take this example, carbon and oxygen, which are having double bond. Okay, then one of these bond is pi bond, and these electrons are called pi electrons in pi bonding. Okay, and when this molecule absorb UV visible light, again absorption of UV visible light, then electron from pi orbital, BMO electron from pi orbital may transfer to anti-bonding orbital. Okay, so this will go here somewhere. Sigma remain as it is. There is no change in sigma. But now in case of pi bond, there is only one electron left over here, and another electron will transfer to ABMO of pi. This is BMO of pi, and here it will go to ABMO of pi. So again, this kind of transition is between BMO to ABMO only. And as it is going from pi orbital to pi star, because ABMO is given star, so we call it pi to pi star transition. So this type of transitions or translational motion occur due to absorption of ultraviolet rays. So here we call it translational motion or translational motion appear due to absorption of ultraviolet visible light. Okay, so this is very, very important, and here it gives a lot of information, not only sigma or pi, even non-bonding electron pair. Suppose oxygen has lone pair of electron over here, it can also travel to pi star orbital when we get different types of transitions. So this is what happens during absorptions of ultraviolet and visible light. Okay, now let us see how we get UV visible spectra. Suppose we take solution in a Q8 transparent test tube, that is Q8, and a light, there will be source of light which has two different sources. One is of UV light, another is visible light. These two lights will be passed through this. Okay, the light which is passing having certain intensity, and this light is called incident light. The intensity of incident light is IO. Now some light will be absorbed. Some light will be absorbed by solution, colored solution, transparent solution, and then some light will pass through. This is called transmitted light. And you can record this light. The intensity of transmitted light is I. Obviously, if some light is absorbed, then that intensity of the light which is absorbed is IABS, absorbed light. Obviously, I0 is always greater than I. Okay, or I absorbed is equal to I0 minus I. Okay. Now, due to absorption of UV visible light, what happens? Let us see this. So, absorption of UV visible light can cause change in three types of motions, which are translational motion, vibrational motions, and rotational motions. Why? Because UV visible is having more energy than infrared and microwave also. So whatever changes appear because of microwave and infrared, that will be caused by UV visible also. And that is why the total energy absorbed is equal to energy required for electronic excitation plus change in vibrations plus change in rotations. So total energy E is equal to E electronic, that will cause mainly due to UV visible absorption. Along with that, we will see vibrations as well as rotations. That means when molecule absorb visible UV, then it gives lines due to rotations, vibrations, and translations. Motions. Okay, that means again there will be many lines together. And when all these lines merge, produce not band but huge peak like this. And this peak is known as UV visible spectra. So normally UV visible spectra is nothing but such a huge peak, and this huge peak is because of consisting of three types of lines: translational lines, rotational lines, and vibrational lines also. Okay, so that is called UV visible spectra. That's it in this lecture. Thank you so much.